Okay, so now we're ready for our examples of new BC content. Woo, 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 woo. Okay, so we are doing a reversing the product rule. All right, so we're reversing a product rule. And we reverse the product rule by doing ultraviolet voodoo. All right, that's your answer on how you do it. All right, ultraviolet voodoo. So what we have to decide here is we have to decide who is going to be your U and who is going to be the DV. All right, who is going to be the U and who is going to be the DV. Now, remember, you're going to be taking the derivative of the U side and you're going to be integrating the DV side. So you want to make sure that you're not making the problem more complicated. So what you choose to be your U, you want its derivative to get simpler. And who you choose to be your DV, you want also the integration to not be difficult. You want it to be simple. So for this problem right here, I'm going to pick my U to be the X and the DV to be the sine X dx. All right. So now I'm going to take the derivative on this side. So the derivative on this side, the derivative of U is going to be a 1 du, and the derivative of X is going to be a 1 dx. Okay. Now for this one, I'm going to do the antiderivative. I'm going to integrate. So to do the antiderivative or integrate dv, that gives me v. And over here, the antiderivative of sine dx is negative cosine. Now, if you're not sure, check it and take the derivative. What's the derivative of cosine? Derivative of cosine is negative sine. So then if I put a negative in front of that, it's going to make it positive. So that way I've double checked to make sure I've done it correctly. All right, so I've got my u, my dv. I took the derivative of this side. I integrated and did the antiderivative of the dv part. So now the answer is nothing but u times v minus the integral of v du. So my u is the x times v, right, which is negative cosine. And then it's minus the integral of the v, and v is negative cosine x. And then the du is the dx. So there's my answer. I just have to keep going and finishing it out. All right, so this is going to be negative x cosine x, and then this is going to end up being a plus sign, right? The integral of cosine, I'll just write it out again. Okay, so now I've got negative x cosine x. So I just need to simplify this. What is the antiderivative of cosine? Well, that's sine. And then we have to add on the plus c. And so that is our final answer. This is the answer. See, I told you it's not near as bad as all that formula and stuff looked. All you got to remember is ultraviolet minus voodoo, ultraviolet voodoo. All right, you just have to pick who's your U, who's your DV, just put it in this ultraviolet voodoo formula, and then you actually simplify the integral because the derivative of sine is cosine, right? So the antiderivative of cosine is sine. And that is your answer. All right, so that is your answer. Now, there is another way to do this which doesn't work all the time. It's called the tabular method. All right, it doesn't work all the time, but it works a lot of time. It works when you have a polynomial as one of your pieces. All right, so here we have x as a polynomial, and the sine is not a polynomial. All right, but we do have a polynomial times something else, and that's when it works best. So this is called the tabular method. So what you do is you decide who is this is still your u side, and the sine part is still your dv side. You set it up like this. Keep taking the derivative until you get to 0, till you can't do it anymore. So the derivative of x is 1, and then the derivative of 1 is 0, and so I'm done. All right, so you just keep taking the derivative because this is the side that you differentiate. Now, on this side, I'm going to do the antiderivative because that's the side you integrate. So the antiderivative of sine is negative cosine. And then I keep going again. The antiderivative of negative cosine is negative sine. Because the derivative of sine is cosine, so then that's going to make that negative cosine. All right, now this is how you put the answer together. Okay, this is called the tabular method and ends up with the same things over here. You do the first one here times the second one, and you keep the sign. Then you do this one the second one times the third one here, and you change your sign. So notice if I multiply x times negative cosine, I'm going to be left with negative x cosine x, and I keep the sign. Then here I'm going to multiply 1 times negative sign, but I'm going to change the sign to a positive. And then plus c. And voila! Notice it's the same answer. Okay, this is called the tabular method, but the tabular method only works when you've got like a polynomial as one of your two pieces you're working with. So it doesn't always work, but it is a nice little method that is pretty easy to work with. All right, so of course the next problem I'm going to show you doesn't work with tabular method, right? All right, so let's go to problem 2. So for problem 2, remember it's ultraviolet voodoo, okay? All right, so what we want to do is we need to figure out who is our U and who is our DV. So already I've given you a problem that doesn't have a polynomial in it, so you can't use that nice little tabular method that I just showed you. All right, so this one's a little interesting. So now I need to figure out, okay, remember your U is always going to be the one you're going to take the derivative of, and your DV is going to be the one that you're going to do the antiderivative of. So since we have ln of x here, ln of x, which would I rather do? Would I rather take his derivative, or would I rather try to integrate ln of x? Well, I better try to do the derivative because we don't know how to integrate ln of x. We have not learned that, okay? We're almost there, but we have not learned how to do that. Notice that's the problem we have, okay? So we don't know how to do the antiderivative of ln of x, which is really the problem we're doing, okay? So I do not want to choose ln of x to be my dv because that puts me in the same position as what I'm trying to solve. So we're going to let u be the ln of x because I can take the derivative of ln of x. That's really easy, okay? So then my dv is going to be the dx, right? So we're going to let the u be the ln of x, and we're going to let the dv be the dx. So now remember, this side you take the derivative. So the derivative of u is a 1 du. The derivative of ln of x, remember the derivative of ln is the derivative of the function over the function. So the derivative of ln of x is 1 over x, remember that? And then that's dx. Over here we're going to do the antiderivative, right? So the antiderivative of a dv is a v. The antiderivative of a dx is a x, all right? So that's good there. So now we're just going to plug it into this nice little formula right here. So we're going to do the u times the v. So we're doing the u times the v. So that's going to be ln of x times an x. I'll put that in front so it doesn't look weird. So it's ln u times v. So it's the ln of x times the x minus the integral of v, which is x, and then the du, which notice the du is 1 over x dx, which the x's cancel. So I've got x ln of x minus the integral of a 1 dx. Okay, so now we just got to simplify that, or actually do the work. So what is the antiderivative of a 1 when you're in terms of x's? Well, that's an x and then a plus c, and this is our answer. So what we're saying is the antiderivative of ln of x is x ln of x minus x plus c. That's the antiderivative of ln of x, okay? Because we just integrated ln of x, and this is your answer. So this is the antiderivative of ln of x. Problem number 3. So this one says to use integration by parts twice, okay? So let's see how this one works out. Notice it also has a t squared in it, which is a polynomial, which means this problem also works with that tabular feature, but I'm going to show you the integration by parts first, and then we'll do the tabular feature, which I know you love already because it's so easy. All right, so we need to decide who our u is and who our dv is. I think it's pretty easy to say that we want to take the derivative, the antiderivative of t squared would be harder, right? That'd be t cubed over 3. So we want to do the derivative of t squared. And then dv, we want e to the t because his derivative and his antiderivative are both really, really easy. So e to the t is the better choice for the dv. All right, so now you take your derivative, du is 2t dt, and then over here you do the antiderivative. So the antiderivative of dv is v, and then the antiderivative of e to the t is just e to the t. So now we're going to do ultraviolet voodoo. All right, so ultraviolet voodoo. So we're going to do the u times the v. So the u times the v is t squared e to the t minus, minus the integral of v and then the du. So e to the t and then the 2t dt. Now, if 2t was the derivative of t, we'd be in business because then we would have the antiderivative real easy. However, it is not. So we have to do the same thing over again. We're going to do the same thing again, all right? So I already know my answer is t squared e to the t minus, and then we got something going on here, all right? So I need to do the same thing over again. So I need to choose a new u and a new dv. So this time, my new u is 2t. My new dv is going to be e to the t dt, okay? E to the t dt. So the 2t is my u, and the e to the t dt, that's going to be my dv. And I'm just going to do the process a second time. All right, so we take the derivative of this part, so the derivative would be du equals 2 dt. Over here, we're going to integrate, so v equals e to the t. All right, so now we're going to do the ultraviolet voodoo again. So notice I set this up. This term is already good to go, t squared e to the t, and then it's minus this integral. So I'm redoing this integral with another ultraviolet voodoo. So that has to go in these brackety things because I didn't want to lose the negative sign that needs to be distributed. So ultraviolet, so 2t times e to the t, so 2t e to the t minus the integral of the voodoo. So that would be e to the t and then a 2 dt. All right, so now we're ready to roll. I can go ahead and distribute the negative. So this is t squared e to the t minus 2t e to the t. And then it's going to be plus the integral of 2e to the t dt. So now I actually have to do the integral. So t squared e to the t minus 2t e to the t plus. Now what's the antiderivative of 2e to the t? Well, you keep your coefficient. Remember, e to the t is its own antiderivative, and then plus c. So voila, we are done. So the answer is t squared e to the t minus 2t e to the t plus 2e to the t plus c. Boom, we're done. So we actually had to do the ultraviolet voodoo twice. And just don't forget, we had to distribute that little negative sign across when we did the second ultraviolet voodoo. All right, now I told you this also works with the tabular method. So let's do this with the tabular method. All right. The tabular method works really well when you have a polynomial as part of one of your terms, okay? So up here in our original problem, we had a t squared. So t squared is a nice polynomial. And then the other term is the e to the t. Okay, and we don't need the dt. You don't write that part. All right, so we're just looking at the two terms. So we're going to keep taking the derivative of t squared until we can't do it anymore. So the derivative of t squared is 2t. Then the derivative of 2t is 2. And then the derivative of 2 is 0. So you just keep taking the derivative until it stops. All right, now over here, you're going to do the antiderivative, right? You're going to do the antiderivative and work backwards. But the antiderivative of e to the t is e to the t. So that's why this one is so easy. The antiderivative is e to the t. Antiderivative of e to the t is e to the t. You just do it as many times as we had to take the derivative over here. Now, you go diagonally. So we're going to take the first term, multiply by the second one here, and we're going to keep the sign. We're going to take this term, multiply by the third one here, and we're going to change our sign. We're going to do this one times this term, and we're going to keep the sign. You just alternate, keep, change, depending on however many times you had to do it. All right, so we're going to take this term, t squared, and we're going to multiply by e to the t and keep the sign. Okay? Then you're going to do 2t times e to the t, and you're going to change the sign. So that'd be minus 2t e to the t. Then we're going to do 2 times e to the t and keep the sign. So that'd be plus 2 e to the t. And then you know it's plus c on the end because we're doing indefinite integration. So now compare that answer to the one we got over here, and it's exactly the same answer. Woohoo! Yay! All right, so this is the tabular method. Works great when you have a polynomial as part of one of your pieces. All right, this one says we're going to have to use integration by parts twice. Notice there's no polynomial, so bummer, no tabular method. All right, use integration by parts twice, and then we're going to do a substitution and then use algebra. All right, so hang in there. We got this one. Okay, so let me show you here. So our u is going to be in our dv. So I think it's pretty easy which one to pick. So e to the x is going to be our u. Sine x dx is going to be our dv. So here we take our derivative. So the derivative is e to the x. Over here we integrate. So v is equal to negative cosine. Get rid of that stray mark. Negative cosine. And if you're not sure, take the derivative. Derivative of cosine is negative sine. So that's why the negative's here. So it cancels. All right. So now remember we're going to do ultraviolet voodoo, right? That's what we do. So we're going to do e to the x times this, so that'd be negative e to the x cosine x minus the integral of v times the du. So minus the integral of negative cosine x times e to the x dx. All right? So now we've got this nice little answer. But we still can't do this integral here. And I can go ahead and minus the negative. I can make those plus. So we still can't do the integral of cosine e to the x. So we got to do the ultraviolet voodoo again. So we got to pick another u and another dv. Pretty obvious again what to do here. So we're going to do the e to the x again as our u and the cosine dx as our dv. So the derivative here, du, is going to be the e to the x dx. Whoops, I didn't write the dx there. Sign that one. Oh, and I wrote the dx in the wrong place. I didn't want that one there. Okay, now we're in business. And then, so the derivative of this is e to the x dx. Over here, antiderivative v equals, the antiderivative of cosine is just sine. All right, and we're taking the antiderivative. So I don't want the dx on the right side. Sorry about that. I want the dx on the left piece. Okay. So this is going to be negative e to the x cosine x minus now what we're going to put in here to replace this integral is another ultraviolet voodoo from these things over here. So ultraviolet would be u times v, so that's going to be e to the x sine minus the integral of the voodoo of sine times this. So that would be e to the x sine dx. Okay, so now what do you notice here that we have? We now have, let me spread this out, and we'll show you a little trick here that we're going to do. We've got negative e to the x cosine x. Let's distribute this negative. That'll be negative e to the x sine x. And then this negative times this is going to be plus an integral e to the x sine x. But you're like, oh my gosh, we're back where we started, man, because this is the integral we started with. It's like, wow, what's going on? All right, so this integral here is the one we started with. It's like, bummer. Well, here's what we're going to do. What have we done so far? We've done that the integral from e to the x sine x dx equals all this stuff we found so far. So this is our original problem. So we're going to say, oh, heck, wait a minute. Our original problem equals this stuff right here. Okay? So now I can move this over to the other side. Oh, wait a minute. This is a plus sign. Yeah, I was like, wait a minute, something ain't working. All right. Yeah, this was a plus sign because I changed the minus negative. This is a plus. So this should be a plus and this should be a minus. If y'all were here, y'all be catching me do this stuff. All right. So because I changed this minus negative here to a plus sign, I really didn't need these little brackety things. I'm just used to doing the brackets in case I need to distribute a negative sign across. But we don't because it's a plus sign. And so then we've got our ultraviolet minus our voodoo. And so I've got this. Okay, so now we're on business. So now, in order to solve this, our original problem equals all of this. So now to solve this problem, we're going to add this over to here. So if I add this integral over to this side, all right, we're going to get two of these, right? Two of these integrals equals this answer, negative e to the x cosine x plus e to the x sine x, all right? So because we had a conundrum and we were like, oh man, I've done this ultraviolet voodoo twice and this integral here is the same as the one I started with at the beginning. What the heck is going on? What you do is you set your original integral equal to our answer that we have here. And it will always happen that you can add this to the other side so that now you got two of them. So now we have two of the integrals e to the x sine x dx. So now to solve for the answer, all you got to do is divide by 2. So the integral of e to the x sine x dx, if we just divide by 2, it's just negative 1/2 e to the x cosine x plus 1/2 e to the x sine x. You're just dividing by 2 is all you're doing. And that's your answer plus C. All right, so this is our answer. So that's the hardest it gets, all right? That is the hardest problem that you'll have is where you integrate twice, and after integrating twice, you end up with the same integral that you started with. And if that happens, you add that integral to the left side. You just set this equal and add it to where you got 2 of them. And then you divide by 2. And that's your answer. Now notice that usually will happen when you have a trig function whose derivative alternates back and forth, right? Because the derivative and the antiderivative of sine alternates back and forth between cosine and sine. Same thing for cosine. So it'll normally happen when you have a cosine or a sine in your problem because your antiderivatives and your derivatives alternate back and forth. So the trick is add it, set it up as an equality, set your original problem equal to what you got so far. You got this integral, which is the same thing you started with over here. So what you do is you add it over there, which ends up with 2 of them, and then you can divide by 2 and then put your plus C on, and that's the answer. That works out every single time, all right, like that. Okay, so now we're to the point about what about definite integration using integration by parts? Well, it's the same thing. If you do definite integration, then you are just going to evaluate both pieces from A to B. So your ultraviolet part is already done as far as the antiderivative, so that you just do the fundamental theorem on. And then on the integral part, you'll put the A and the B, do the antiderivative of this part, and do the fundamental theorem on once you've done your antiderivative of this piece. So doing definite integration is not difficult at all. Okay, so it's the same process to start. Okay, so for this one, let's go ahead and do, oh, it's a polynomial. So let's go ahead and do the tabular feature. All right, so let's do the tabular feature. So I've got x squared plus 1 is my polynomial. So my other piece is the e to the negative x dx, but I don't need to write the dx beside that. So what I'm going to do is I'm going to take the derivative of this until I can't take the derivative any longer. All right, so the derivative of x squared plus 1 is 2x. Then the derivative of 2x is 2. And then the derivative of 2 is 0. All right, so I was able to do it 3 times. So now you come over here and do the antiderivative of e to the x. So the antiderivative of e to the negative x is negative e to the negative x. All right, so think about it backwards. The derivative of this would have a chain of -1, which would make it positive. So you kind of have to reverse your brain there. The antiderivative of negative e to the negative x is e to the negative x. And then the antiderivative of that again would be negative e to the negative x. All right, so you're doing the antiderivatives. Remember that. So now to do the problem, we're going to alternate, go diagonally, and we're going to keep the sign here, change the sign there, keep the sign there. Okay, so what do we end up getting? We've got x squared plus 1 times a negative e to the negative x. Then here we're going to change our sign, so that's going to be a negative 2x e to the negative x. Then here we're going to keep our sign, so that'll be a negative 2 e to the negative x. Now, if I was just doing a regular problem, I would put a plus c on this and call it a day, right? But we are doing definite integration this time, so I need to put my little bracket. My limits of integration are 0 to 1, okay? So now I'm just going to do the fundamental theorem of calculus. So I'm going to put a 1 in first. So we're going to put a 1 in here, so negative, and then put a 1 in here is going to make a 2 e to the negative 1 minus 2 times 1 e to the negative 1 minus 2 e to the negative 1. Okay? Then we're going to put a 0 in everybody. So putting a 0 in here is going to make this a negative 1 e to the 0. Putting a 0 in there, that's gone. And then, so that'll be minus 0. Go ahead and write it. And then this one, putting a 0 in here is going to be a minus 2 e to the 0. So what do I end up getting? I end up getting negative 2 over e minus 2 over e minus 2 over e, and then here e to the 0 is just 1, so that's going to end up being a plus 1, and then that's 0, and then e to the 0 is a 1, so that's negative 2, but we're subtracting, so that'll be a plus 2. So this gives me negative 6 over e plus 3, and that's the answer. So negative 6 divided by e plus 3, and that gives me my answer. Woo, 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 done, done, done. All right, next problem. We're going to integrate from 4 to 9, ln of y divided by square root of y dy. All right, so to do this, I need to decide who is going to be my u and who is going to be my dv. Now remember, my u needs to be something I can take the derivative of real easy. My dv needs to be something that I can integrate easily. Well, we don't know how to integrate ln of y unless we go back to that other problem, the answer we got, which was messy. So we're going to do the ln of y as our u and the 1 over square root of y dy as our dv. All right, so now you're going to do your derivative. So the derivative of u is du. The derivative of ln of y, remember ln of y is the derivative of the function divided by the function. So then that's going to be a dy. Over here, we're going to do the antiderivative of this. All right, so that's going to be a v equals, and we got to think about the antiderivative of this. So think about what this would look like as a power, right? So this is going to end up being y to the negative 1/2, right? Y to the negative 1/2, because we're in the denominator, square root is 1/2, so that's y to the negative 1/2. So I want to do the antiderivative of this. The antiderivative, I would add 1 to it. So adding 1 would be a positive a half. And then instead of dividing by a fraction, I'd multiply by the reciprocal. All right. So that means my answer is 2 square root of y. So that's my answer, 2 square root of y. Okay. All right. So now we're going to do, remember it's ultraviolet minus voodoo. All right. Ultraviolet voodoo. So it's the U times the V. So that means it's going to be ln of y times the 2 square root of y. I'm just going to put that in front so it looks all right. Okay. Then it's minus the integral of v du. So v du. So v is 2 square root of y, and the du is 1 over y dy. Okay. So now I need to simplify this. So this part is good. 2 square root of y, ln of y is good. Here I need to do some simplifying so that I can actually do the antiderivative. So I just need to put these two guys together. So this is y to the 1/2, right? Which I could have left at that, I guess, maybe make it easier. And then it's 1 divided by y. All right. So when you have a 1 divided by y, that means that's a y to the first in the denominator. And remember, we subtract powers. So this is a 1/2 minus 1. So we're going to end up a y to the negative 1/2. All right, so that's going to be y to the negative 1/2. So now you can actually do your antiderivative. So when you do your antiderivative, you keep your coefficient. Remember, you add 1, so that'll be y to the 1/2. And then instead of dividing by a half, you multiply by the reciprocal. So we're going to multiply by 2. And then it's a plus. Oh, we don't need the plus c. My bad. We don't need the plus c because we're evaluating from 4 to 9. Okay, so now I'm going to do the fundamental theorem of calculus. So I'm going to put a 9 in first. So 2 square root of 9 ln of 9 minus 4. And then it'll be 9 to the 1/2. And then we're going to put a 4 in. 2 square root of 4 ln of 4 minus 4 times 4 to the 1/2. So this is going to give me 6 ln of 9. Which is probably about as far as I'm going to take that. And then the square root of 9 is 3 times 4. That'll be minus 12. And then here we're going to have 2 times 2 is 4. So 4 ln of 4, and that'll be subtracted. And then here, square root of 4 is 2. 2 times 4 is 8, so that's a minus 8, but we're subtracting a minus 8, so we're adding 8. So my final answer is going to be 6 ln of 9 minus 4 ln of 4, and then the minus 12 and the plus 8 will make a minus 4. So unless I was using a calculator, that's going to be my final answer. Unless I was using a calculator to actually get a decimal equivalent answer or something. All right. Next problem, number 7. I just got one more after this and we'll be good. All right, this one's looking like it would be a good tabular problem because I've got a t squared and then I've got sine of 2t. So derivative of sine squared is 2t, derivative of 2t is 2, derivative of 2 is 0. Then I want to do the antiderivative. This is where I kind of thought, you know, the mental math. Remember when I gave you that mental math one to do to try to figure out, you know, could you do this mentally? The antiderivative of sine of 2t is going to be the cosine 2t. But remember, this has to be chain rule, so we need a negative 1/2 because the derivative of cosine is negative sine. So I need a negative to make it positive sine. And remember, this is going to have a chain of 2 on it, so I have to have the 1/2 to cancel away because there's no fraction up here. Then I'm going to do it again. The antiderivative of negative 1/2 cosine 2t, well, that's going to be a sine of 2t. But I got to think about reversing that power rule, reversing that chain rule again. So this is going to end up chaining on a 2, so I need to have half as much in here, so this will be negative 1/4. All right, so think about taking the derivative of this. If I take the derivative of this, the derivative of sine is cosine, and then I have to chain on the 2, and when you chain on the 2, that makes that a negative 1/2. So I just want to make sure that when I do the derivative of this, I get this guy up here That's usually how I do it to make sure I've done it correctly. Because doing this antiderivative of these kinds is a little harder. All right, and again, the antiderivative of the sine is going to be the cosine, and it's negative, right? And so that's going to end up making it a positive, and with the chain, that's going to make this a 1/8. So again, if I take the derivative of this, the derivative of cosine is negative sine, and then you're going to do a chain rule of 2. So when you multiply 2 times this 1/8, you get the 1/4. So just you want to make sure that the derivative going this way gives you the correct answers, because you're actually doing the antiderivatives. All right, so now once you've got this done, you're going to do diagonally. We're going to keep the sign. Here we're going to change the sign, and then here we're going to keep the sign. It just alternates back and forth, keep, change, keep. So my answer is going to be t squared negative 1/2 t squared cosine 2t. And then here we're going to change the sign. So it's 2 times 1/4, which is going to be 1/2. Yep. And we're going to change the sign. So it'll be positive 1/2 t sine of 2t. Then here we're going to keep the sign. So 2 times 1/8 is going to be a 1/4. And we're going to keep our sign, 1/4 cosine 2t. I would put a plus c. However, I'm doing definite integration from 0 to 2 pi. So I don't need the plus c. All right, so now we're going to do the fundamental theorem of calculus. I'm going to come down here so I got plenty of room. So I'm doing the fundamental theorem of calculus. So I'm going to put a 2 pi in here first. So this will be negative 1/2 2 pi squared cosine of, putting 2 pi in here will be 4 pi, plus 2 pi times 1/2 is just going to be pi, and then sine of 4 pi. And then plus 1/4 sine of 4 pi. Then I'm going to put a 0 in all this. So if I put a 0 in here, that's going to be go away, because 0 squared, that'll be 0. Putting in a 0 here, that t will be 0, that'll go away. So then putting a 0 in here, I'll have 1/4 cosine of 0. Whew, wasn't too bad. That wasn't too bad. All right, so now let's go through and work this out. So the cosine of 4 pi, well, the 4 pi is the same place as 2 pi on the unit circle, which is the same place as 0. So what is the cosine of 0 on the right side of the unit circle? Well, that is 1. Because remember, cosine's your x-coordinate. And then what's the sine over there? Well, the sine over there is 0. So these guys are both going to be 0. So these guys are both gone. All right, so the cosine of 4 pi is 1. So it's just going to be 1 times this. So 2 pi squared will be 4 pi squared. And then you got half of that, which is going to be 2 pi squared negative. And then over here, cosine of 0 is 1. So this will be minus 1/4. And that is our answer. Wait a minute. Oh, I copied this guy wrong. Gosh, I wish y'all were here with me. You'd catch me doing this stuff. This right here is cosine of 4 pi, because I copied this guy wrong. All right, cosine of 4 pi, which is 1, and that gives us another plus 1/4, so these guys cancel. So the answer is only negative 2 pi squared. There we go. It helps if you copy correctly. All right, because this was cosine, this one was sine, this one was cosine. All right, and the cosine of 4 pi is 1, which leaves me with a plus 1/4. And then over here, that was a minus 1/4, so they cancel. So the answer is just negative 2 pi squared. That's right now. All right, if y'all were with me, y'all catch me make those mistakes. All right, last one. And of course, I had to put an inverse trig one in here. Yuck, 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 right? All right, so we want u and our dv. So for this one, the easiest way to do an arctan, it's a lot easier to do his derivative than it is to do his antiderivative. So we're going to let our u be the inverse tan, all right? And we're going to let our dv just be the dx, all right? Now, we're going to take the derivative. So du equals, if we go back to all the arcsecant, arcsine, arctangents, the derivative of arctan is 1 over 1 plus x squared. So he's the easiest one to do the derivative of. Pretty easy. No radicals or anything. And then here we're doing the antiderivative. So the antiderivative of each of these, v equals x. So remember, we're doing ultraviolet minus voodoo. All right. So we're going to do ultraviolet. So that's x inverse tan of x minus the integral of voodoo. So x times 1 over 1 plus x squared dx. All right. Now, the nice thing about this guy, let me write him a little better because this looks like a scary problem, but it's not. X over 1 plus x squared dx. All right. This is where we did the mental math stuff, the mental math worksheet that I had you do. If you look at this, the derivative of 1 plus x squared, the derivative of that is 2x. So if this was a 2 right here, this would be perfect. So I'm going to put a 2 here and put a 1/2 outside so they cancel. So now this is ln of 1 plus x squared. And so it's just going to be that. So I kind of cheated a little bit by forcing my numerator to be the derivative of the denominator by putting a 2 in here. And I can put a 2 in there as long as I cancel it out here with a 1/2, because now these guys cancel each other. So I haven't changed the problem. I just changed what it looked like to make doing the math a whole lot easier. So now we evaluate from 0 to 1. So now I just do the fundamental theorem of calculus. All right. So I put a 1 in here. So it's 1 times the inverse tan of 1 minus 1/2 ln. Put a 1 in here. That's going to be 2. Then when you put a 0 in there, well, that's going to be 0. So it'll be 0 minus 1/2. And then putting a 0 in here will be ln of 1. Now we know the ln of 1, that's 0. So all this is 0 back here. Good deal. So now what is the inverse tan of 1? So that's asking us what angle on the unit circle has a tangent value of 1. So who on the unit circle, remember tangent is sine over cosine, so that would be y coordinate over x coordinate. So who on the unit circle, y coordinate divided by x coordinate, is going to give you an answer of 1? Well, that's pi over 4. And then here, this is just going to stay minus 1/2 ln of 2. That can just stay that way. And there's your answer, pi over 4 minus 1/2 ln of 2. All this went to 0. So now you know how to undo product rule by using ultraviolet voodoo. Ultraviolet minus voodoo. Ultraviolet voodoo. You need to remember that. All right. And these can get a little tricky, but you'll be fine. All right. Just keep referring back to. Now, the assignment I'm giving you is actually out of your textbook. So you're not getting a worksheet or anything. So you're actually going to be doing page 468 in your textbook, these problem numbers, 1, 2, and then 3 through 19 odd. All right, so those are the problems that you're going to work on and upload a picture of into Canvas for me so that I can see your work and we can talk about them if we need to during our Zoom time. Now, and then you've got your target assessment that I always have you do every time. So enjoy doing ultraviolet voodoo.